Hey everyone, this is lesson 526, introducing complex numbers. This is the last of the lessons in chapter 5. We've been solving quadratic equations, and there's been one type of problem we have not been able to solve. And so we're going to try to uh, address that issue in this lesson. So, a reminder of something you need to know. You might know this, you might not. You might know it and not realize that you know it. And that is what real numbers are. So, uh, usually when we first learn numbers, probably in elementary school, you learn counting numbers, you learn how to count 1, 2, 3, 4. And then later on, you start to learn the difference between positive and negative, or rational and irrational. Most likely, the names weren't introduced to you till a little bit later, maybe not till now. But for the most part, our set of numbers that we've been working with, real numbers, which is pretty much any number you could think of, includes some numbers that you might recognize. For example, the number 0, right? So 0 is considered a real number. We have positive and negative rational numbers, right? So you understand the difference between positive and negative, but rational, maybe you know this or don't know this. Another word for rational might be fraction, something that could be written as a fraction. And some numbers that I have as examples are maybe 999. That's a rational number because that definitely could be written in a fraction form. It reduces to a nice whole number. Another example would be negative 2, simple number, positive 2, negative 2. So any number that you might actually find on a number line is considered a rational number. So sometimes the fractions don't reduce. So maybe something like 237 over 238. So that's still considered a rational number. All right, so both of those, all rational numbers, are considered real numbers, including the number 0. And also included in real numbers are irrational numbers. And so the difference between a rational and irrational number is it's really irrational numbers are numbers that never end. They're decimals that we see that never end. So if you go to a calculator and you put square root of 2, it's going to give you a decimal number that never ends, right? It's going to keep going on forever. And those numbers don't repeat. So there's no pattern to the decimal numbers. Another example might be maybe a number you're familiar with, pi 3.14156, and it keeps going on forever and ever. So that's considered an irrational number. All right, so it's nice to know the difference between the names of these numbers. So I've listed those out for you just so you have as a reference. Irrational, rational, 0. These different sets of numbers are considered included in this real number. All right, so why do we need to know that? Well, the issue we've had is coming across problems like this. So if we're trying to solve x squared equals to -4, or maybe x squared plus 1 equals to 0, we've come across an issue. And so what is the issue here? So I'm going to zoom into this for a second. So if I'm trying to solve this, if you don't remember, we would most likely square root both sides. Remember, we would square root both sides, and we're left with something like this. X equals 2 plus or minus the square root of -4. And so if you remember, the issue we had here was there's a negative inside the square root. And if you put this in a calculator, it's going to give you an error message, or it'll either say error or undefined. And that's something that we can't work with. So maybe same thing here on this problem. If I subtract 1 from both sides, you'll notice that I'm left with x squared equals to -1. And then if I square root both sides, I'm going to be left with x equals to plus or minus the square root of -1. Again, we have a negative in the square root. We were able to find solutions, but in previous lessons, I would tell you, really the answer is there's no real solution, right? So I kept saying there's no real solution, but it is a solution. It's just not a real one. Okay, so what did I mean by that? Well, because this, about 500 years ago, there was this mathematician, Raphael Bombay, he invented a new type of number. So he came across this issue in all the math problems he was solving, and he felt like he needed to invent or make up a new number in order to deal with this situation. All right, and so what he imagined, right, is really out of his own imagination. He came up with something that we now call imaginary numbers. And so it's quite simple. It's not a big, really it's not a big collection of numbers, but it's this one idea that says, and it's really what he said at the time, that anytime I come across the square root of -1, I'm going to replace it with the letter I. Right? He just thought, you know what, this square root of -1, every time I come across it, it's always a big headache. It always stops me from going further. And so he got so tired of that he decided to replace all the square roots of -1s with the letter I. And so because he did that, he was able to continue on in solving his problems, and eventually he would end up with a solution that he knew was true. And so with this one idea, he understands that if I and the square root of -1 are really the same thing, then that must mean that if he squares both sides, right, if he actually squares both sides, then that's going to mean I squared is equal to -1. And so what this does is it really gives us a way to go from a real world to an imaginary world. So we're living in the real world, but how do we get to the imaginary world? Well, this is how we do it. So I squared, right, this I represents imaginary numbers. So anytime we have the square root of -1, which doesn't work, we're going to want to use our imagination and use I. But sometimes we might actually want to go the other way, from imaginary to a real number. And so the way we do that is we notice if we square both sides, if we have an I squared, which is imaginary, we could actually convert it back to a -1. And if we replace I squared with a -1, then that takes us back to a real number. So I like to think of this as really like a portal between imaginary and real. So this is the beginning of a new type of number that we're going to be working with today. This is the beginning. This is not even it, but this is part of it. So first thing is imaginary numbers. So by replacing the square root of -1 with I, then really the impossible became possible for us. So we're going to use that to help us solve some problems. All right, so for example, like I just solved earlier, we have x squared plus 1 equals to 0. And if I solve this, right, subtract 1 from both sides, take the square root of both sides, and we're left with x equals to plus or minus the square root of negative 1. So normally we would stop here, right? Normally we would stop and we would say no real solution. But we just learned, in this moment, we just learned about imaginary numbers. And imaginary numbers said that anytime we see the square root of negative 1, we can replace it with the letter I. So I've already separated them into our two solutions, which are not real solutions. And I could replace this square root of negative 1 with the letter I. And I can replace this square root of negative 1 with the letter I. You'll notice this negative in front still stays there. And now I have two solutions, right? These are the solutions to this problem. They just happen to be imaginary numbers, right? That's the only difference. All right, so let's try this with x squared plus 16 equals to 0. This would, if you want to try to work this one out, I would say pause it right now before you see the answer. If you want to test yourself out, see if you got this. If you could solve this completely. All right, I'll give you a second. All right, I'm going to start solving this. All right, so I'm going to subtract 16 from both sides. This is going to leave us with x squared equals to negative 16. As I solve, I'm going to square root both sides. You'll notice I still have that plus or minus square root on the right side. I'm left with x equals to plus or minus the square root of negative 16. All right, so again, I notice I have a negative in the square root, which means this is not a real solution. But doesn't mean we can't keep going. I'm going to separate this into x equals to square root of negative 16 and x equals to negative square root of negative 16, right? Plus or minus goes in front. All right, so normally we would stop here, but we just learned about imaginary numbers. So I notice here I do not have a square root of negative 1. So what would I do? All right, so there is a square root of negative 1 here. We just can't see it. So let's pull it out. Let me show you where the square root of negative 1 is so that we could go a little step further. So this square root of negative 16 is really the same thing as square root of 16 times the square root of negative 1, right? 16 times negative 1 gives you negative 16. All I did was I factored out the negative 1. All right, so you'll notice I still have the square root on both of these. And I'm going to do the same thing on the other one. X equals to negative square root of 16 times the square root of negative 1. All right, so because I have these, I can replace that with the letter I. At the same time, you'll notice square root of 16 actually reduces as well. So our final answers are going to be square root of 16 is 4, and the square root of negative 1 is I. And so this is going to be a negative for I as well. All right, that one's a little bit tricky. And so we have two imaginary number solutions. So did a little different than that first one where it was very straightforward, just putting i's and negative i's. Here we actually see it with numbers involved. All right, so all we had to do was separate that square root from the other, from the rest of the solution. All right, moving forward. So let's practice this a little bit. Let's see, there are There's about 4 of these that we could practice. And so I'm going to go through all 4 of these. If you want to, I think I'll ask you maybe with the solutions. See if you could do A right now and see what you get. And then I'll ask you, see if you got it correct or not, and then I'll solve it. All right, so I'm going to start working this one out. And I'm going to do, all right, so square root of -4, this is very similar to the problem we just did. What I'm going to do is I'm going to separate these. I want to have my square root of 4 times the square root of -1, right? I'm just separating the -1 from the rest of the number. By doing that, it allows us to convert that unreal number into that imaginary letter I. So square root of 4 is 2, and this square root of -1 is I. Right, and then that's it. That's the answer. All right, let's see on B. Take a second to work out B. If you haven't already done it. All right, so anytime, even though we have this letter I, it's the same as if it was the letter X, right? Treat it the same way. So like if it was 2x times 2x, right? If it was 2x times 3x, sorry, what would you do? What would that look like, right? Just because it's a different letter, this letter I doesn't change all the operations that you would normally do. So I would probably rewrite this. I'll zoom into this. So this is, it's really the same thing as 2 times 3 times I times I. All right, that's really what I'm multiplying here. Right? Everything's multiplication. So the numbers 2 times 3 is 6, and I times I is I squared. All right, that's pretty straightforward. I times I is I squared. Just like if it was x times x, it would be x squared. But if we have an opportunity to convert an imaginary number back to a real number, then we try to take that opportunity. So I squared can be replaced, right? We said earlier that I squared is the same thing as, I'm going to put parentheses here, it's the same thing as -1. Right? Those are the same thing. So not square root of -1, right? I is the square root of -1. I squared is -1. All right, so this is 6 times -1, which is -6. Right, and that's your answer. Right, that's your answer. All right, and then let's see, -5 times 2i squared. If you know your exponent rules, you would have to distribute your exponent to everything inside first before you would not distribute the -5. So explanation of y, I would probably say, think about it, 2i squared is really the same thing as 2i times 2i. Right? There's 2 of them. So if you separate it, it kind of makes more sense. All we're going to do is really the same thing like we did over here. So I'm going to multiply all the numbers. So I have a -5, 2, and 2, which gives us a -20. And I have an I and an I that I can multiply, which gives us I squared. All right. So we don't want I squared, so I'm going to replace the I squared, this I squared, with -1, right? Because those are the same thing. And then one more step to simplify, -20 times -1. This is not -1, this is times a -1. So this is going to be negative times a negative is +20. All right. And then the last one, see if you know the answer to this one. I'll let you type, solve this, and then see if you could answer this one for part D. All right, so let's separate this. So square root of 25 times the square root of -1, right? So that other number, if it was a square root of 24 or 26 or 27, it might reduce, it might not reduce, but we still want to take out that negative to separate it. In this case, it's a nice perfect square. So 25, square root of 25 is 5, and the square root of -1 is I. And that's it. All right, so hopefully you got that correct. All right, so that's the general idea of imaginary numbers, which is just the first step really to the numbers that we're trying to get to, and that is complex numbers. And so it's nice. We've been living in this real world, and then sometimes there's this imaginary world that we hear about, or sometimes maybe some of us are completely living in an imaginary world. But when you bring those two worlds together, if you bring real and imaginary together, that's where things get complex, right? Literally, it's very complicated. And so that's what we refer to as complex numbers. All right, so let's see. So here we have the general format of a complex number. So it's going to be some real number, right? We talked about real numbers earlier. And plus or minus, right? It might be a plus, it might be a minus. Some multiple of I, multiple of an imaginary number. So it could be 1i, 2i, 5i, right? It's going to be some number, right? So the general format looks something like this. A would be a real number, plus or minus bi, right? Where bi represents that imaginary part. All right, so this first part is real. The second part is imaginary. Oops, real. But together, right? But together, when we add them together, is when it's complex. So those are names you need to know. Real numbers, imaginary numbers, together they're complex numbers. So in the end, most numbers can be written as a complex number. So that's kind of like the bigger umbrella of numbers that we're normally working with. All right, so where do we see complex numbers? All right, so here's an example of a function, f of x equals to x squared minus 4x plus 5. So if we actually graph this, so sketch a picture of this, and you notice it's a parabola like we've seen before, and we ask the question, does the graph cross the x-axis? Right? Yes or no? And so I would look at the x-axis and see, does it cross the x-axis? And the answer is going to be no. No, it doesn't. All right? Okay, so just simple observations. Does x squared minus 4x plus 5 equal to 0 have real solutions? All right, so if we solve this, are we going to have real solutions? Right, if you're thinking about it, if you're like, oh, I don't want to solve it, I don't know, I'm not sure if it does or not, you're thinking way too hard. because the first question just answered it for us. So if it crosses the x-axis, then that means it has real solutions. So since it doesn't, right, so the answer is going to be no real solutions because there's no x-intercepts. All right, so if there's no x-intercepts, if it's not crossing here, then that means there's no real solutions. It's impossible. This x-axis represents all real numbers, right? This is all real numbers. Any number you could think of is going to be somewhere on this x-axis. All right, well, if that's the case, well, then let's solve it and see what we get. All right, so we're going to solve this using quadratic formula. You could use completing the square as well. I think quadratic formula works a little bit better for this one. And what we're really going to be looking for are what we call roots. Here's a little side note definition. This term roots, it refers to the values of x that make the function equal to 0. Right? Normally we call them solutions or x values. It's just another name you need to know. Roots. So if I say find the roots of this function, that just means solve it and tell me what x equals to. All right, so I'm going to plug these in. We need to know our ABCs. What is A equal to, what is B equal to, and what is C equal to. All right, so that's something worth asking you. Do you know what these values are? All right, so in this case, our A value is the first coefficient, the number in front of x squared. So that means A is equal to 1. B is equal to -4, right? Not just 4, but there's a minus there as well, so it's -4. And then C is going to be equal to 5. All right, so those are the 3 numbers we need to use to plug into our quadratic formula. I've already set it up for us, the format. If you don't know quadratic formula, you need to probably look at your notes to reference that. But what we're going to do, I'm going to zoom into this. I'm going to plug in my B value. So -4. So it's negative B plus or minus square root of B squared minus 4AC over 2A. And we're going to plug in the numbers that we have. So let me see. This is going to be 1 and 5 and 1 at the bottom. All right, so let's simplify this. And this is going to be x equals to negative times the -4 is +4 plus or minus the square root. -4 squared, that's -4 times -4 is +16. Minus 4 times 1 times 5. So if I simplify this portion, this is a -20 over 2. All right, so that means we're going to end up with a square root of -4 on the top divided by 2. All right, so I already see the square root of a negative number. That tells me we do not have real solutions, which is okay, because now we have a better idea of how to simplify this. All right, so let's So what I'm going to do is I'm going to do 4 plus or minus. Now square root of 4 is square root of, well, square root of -4 is square root of 4 times the square root of -1 over 2, right? We could separate that. And that -1, square root of -1 can be written as the letter I. So let me see if I could fit this in. I'm going to go up here. So we have x equals to 4 plus or minus. The square root of 4 is 2. And the square root of -1 is I over 2. All right. So we have solutions, right? We have solutions. This can be simplified a little bit more because it's a fraction. This 2 actually goes in, this 2 can go into both portions. So I'm going to separate this to x equals to 4 over 2 plus or minus 2I over 2. All right, all I'm doing is I'm separated into two fractions, both with a denominator of 2, and each of those can be reduced. So 4 over 2 is 2 plus or minus, you'll notice 2I divided by 2 is I, right? So actually it's a nice number. All right, so here are this is what we call our complex roots, or complex solutions. Right? Complex solutions, complex roots. You could separate them into 2 plus I or 2 minus I, x equals to 2 plus I, and x equals to 2 minus I. All right, those are our two solutions. All right, a little bit more. Sorry, this is a little bit long, but there's just so much to do in this one lesson. All right, so if we are trying to find the roots of equations like this, we have three equations. We don't always want to do a lot of work, and so we look for ways to avoid it at times. And so if I have these three equations, I have the graphs for us so we could look at the graphs. If we could find the roots, solutions, or x values just by looking at the graph, then that would make it easier for us. And so the nice part is we can. So if I'm looking at this first one, right, here's the equation and the graph of it. You'll notice it has x-intercepts, right? All I have to do is look at the x-axis, and that's going to help us find our solutions. And so right away, I could tell I have, this is going to be x equals to -5, and this is going to be x equals to -1. Right? Those are our solutions. Right? No work needed here. We just needed the graph. So that makes it pretty easy. All right, so the second one, is it just as easy? Right? You'll notice the difference in equation x plus 3 squared, This one has a -4. This one doesn't. Does it matter? Well, when we look at the graph, does it touch or cross the x-axis? Well, it does. So I notice there's this one point, and this is at x equals to, what is that, 1, 2, 3, -3. All right, there's only, so far, let me put this, there's two real solutions, right? These are real numbers, -5 and -1. This one has one real solution. All right, and then the last one, this one looks the same. You'll notice the only difference is this is a -4 on the first one, and this last one, it's a +4. And look at the graph of this. Does it cross the x-axis? Right? No, it doesn't. So this is an example of where we do not have real solutions. There are no x-intercepts. So that tells us we're going to have complex solutions. So then we would have to solve this. So if I solve this, this is going to be x plus 3 squared plus 4 equals to 0. If I set it equal to 0 and solve, what does it give us? Well, I'm going to subtract 4 from both sides. So I'm left with x plus 3 squared equals to negative 4. And then we're going to square root both sides. So this is going to be plus or minus the square root of negative 4. You could already see how that solution is becoming complex. And then I'm going to subtract 3 from both sides. So this is x equals to negative 3 plus or minus the square root of negative 4. Here, I'll zoom into this. All right, so you'll notice this looks very similar to the format that we want. The only thing left to do is get rid of that negative in the square root. So let's change this to x equals to negative 3 plus or minus the square root of 4 times the square root of negative 1. So that means we could simplify this to negative 3 plus or minus 2 times I. All right, so now we have two solutions. I'm not going to separate them here, but we have two complex solutions, or roots, right? So notice the difference on the graphs. Notice the difference on how many solutions we have, and notice what type of solutions. Are they real? Are they complex? So this is definitely something that we're going to be practicing a lot more of on the second semester. All right. And then the last thing that I want to go over is just a little bit more practice on complex numbers. So, and working with our imaginary numbers, the letter I. So here is 3, 4, 5 types of problems, common test questions, common probably homework problems where you need to just simplify it as much as you can. All right, if you want to work these out, pause it and work them out before you see all the solutions. I'm going to probably try to go through these faster without explaining too much, but you know me, it'll probably take longer than I think. But our goal is to rewrite these, simplify them as much as possible. Remember, treat it, that letter I, like if it was an x, and then when there's a right moment to convert like an x squared to a negative 1, you do it. If you can't, it's okay to have i's in your answer, as long as it's in the right format. All right. So, all right. So 2 times 3 plus I. All we're looking to do here is really distribute. So I'm just going to distribute that 2 to everything. So this is going to be, it's really 2 times 3 plus 2 times I, right? Distribute that 2 to everything, which is 6 plus 2I. And that's it, right? Complex number, right? That's our complex number format. 10 minus 9I minus I. So we're combining like terms. So I have a negative 9 and a negative 1. This is really like a negative 1I. So that's the same as 10 minus 10I. Right? These are not like terms. Don't be tempted to subtract these. This has an I next to it. This one does not. All right, so that we would stop there. All right. All right, same thing here on C. We're just trying to combine like terms. We have a complex number plus another complex number. We're just adding 2 complex numbers together. Just like any other numbers, we're just adding them together. So I'm going to start with getting rid of these parentheses, negative 2 minus 7I. But there's a plus here. You need to make sure, there's really no work to do here, but the reality is this plus gets distributed to everything inside. But when you do multiply a positive, really it's like a positive 1 to everything, nothing really happens. So what we end up with is negative 1 plus 4i. So let me move this over a little bit. All right, so now there's no parentheses. I'm going to combine like terms. So we have a negative 2 and a negative 1, and we have a negative 7i and a plus 4i. So that's going to be a negative 3. With the real numbers and the imaginary, it's going to be a negative 3i. All right. And then this next one is almost the same, except there's a minus here instead. And so this changes things because when we start to solve this, first one I could get rid of the parentheses. Nothing's changing there. But what I do need to make sure I'm careful with is that this negative gets distributed to everything inside. So negative times 1 becomes negative 1, and negative times a negative 6 becomes positive 6i. All right, so now we could combine like terms. I have negative 8 and negative 1, and I have a positive 2i and a positive 6i. All right, so that's negative 9 plus 8i. All right. Almost done. And this last one looks like the others, but it's different because there is no plus or minus. These are being multiplied. We've done this before. You could use an area model on these. So if you wish to use an area model, that might be a good idea. Let me just do that really quick on the side. So this would be, let's see, I'll do 1 minus I and 8 minus 6i and just multiply. So inside I would have negative 8i. Let me zoom into this. Negative 8i, and this would be a positive 8. This would be a positive 6i squared, because I times I is I squared. And we have a negative 6i. All right. So now all I'm going to do is write those on the outside. So I'm left with 8 minus 8i minus 6i plus 6i squared, right? All four terms, I'm just writing them outside of the area model. And then I'm going to combine things that I can't combine. The only thing I see so far I could combine is these two in the middle. So I'm left with 8 minus 14i plus 6i squared. All right. Now this is different because now we actually have, this is the first time we've actually had an I squared that we could turn it back into a real number. And so what I'm going to do is we have 8 minus 14i plus 6, and I'm going to replace, I like to replace the I squared with parentheses, and then inside the parentheses I'm going to put negative 1. That's not a minus 1, that's times a negative 1. So that means I have 8 minus 14i minus 6, which now gives us an 8 and a negative 6 we could combine, which is 8 minus 6 is 2 minus 14i. All right, so you'll notice I kept the same format, real number minus an imaginary number. All right, that's a lot. We've gone over tons. You need to know how to do all this. And then hopefully on your homework you should get more practice of this. Definitely ask questions. because there's no more lessons specifically on complex numbers. All right, thank you.